Okay, so we're going to go through section 1.4 on solving absolute value equations. And you probably actually did this in Algebra 1, but I'm going to take it from the beginning. Okay. First, the author defines absolute value. Of a number. Absolute value of a number is actually the distance from 0 on the number line absolute value of a number is the distance from 0 on the number line without regard to the direction. Without regard to the direction. So just as an example on the number line, if I said if I said the number 2, the absolute value, and they use this symbol, the parallel lines, and if I said how many spaces is that from 0, you just count spaces, and it's 2 spaces from 0 on the number line. If I said the absolute value of -3, you count the spaces from 0, and -3 is 3 spaces. So that is considered the absolute value. Okay? So that's a real good definition to use. Okay? It's the distance from 0 on a number line without regard to the direction. So if I said absolute value of 0.5 would still be 0.5. If I said absolute value of a -0.3 would still be 0.3. Okay, it's always going to be, yeah. Even if you said count spaces, if I split the ruler up or the number line up into tenths, yeah. Same thing on fractions. Like if I said, what's the absolute value of 1/4? I mean, that's a good question. It's still 1/4. If I said, what's the absolute value of a -3/5? It would still be 3/5. You'd just break your number line up into fifths. Okay. If it was, like say my answer was 6/5, I'd reduce it. Yep. Yeah, everything from now till the end of the year is reduced. Geometry kids, can you vouch for that? Yeah. Yes. Yeah. All the way through. It's like No, you don't have to. I would just leave it in fraction form. Yeah, you don't have to go to mixed number. You just say that is 6/5. Yeah. It would not be wrong if you changed. I mean, these are equivalent. Yeah, I'd take either one. Okay. Okay, so definition-wise, for any, and use a double bar R for real number. For any real number, A, the absolute value of A is equal to A if A is greater than or equal to 0. Or the absolute value of A is equal to the opposite of A if A is less than 0. Now, you gotta be careful with this. You gotta substitute in. Okay, so if A is like 5, absolute value of 5 is 5 if A is greater than or equal to 0, because 5 is greater than or equal to 0. But let's say A is less than 0. Let's say A is -2. Okay, so if this said the absolute value of -2 is, what's the opposite of a -2? 2. So this is still going to end up to be a positive answer. Okay, it's just the way they define it. Okay, so it basically fits with the definition up above. Okay, and I always go by example and say, like, absolute value of 5 is 5. Absolute value of -4 is 4. Absolute value of -8. Now, what if the author does this? Okay, sure enough, the author's always going to change something. Absolute value of -8, and then they put the opposite sign on the outside. So, absolute value of -8 is 8, and now take the opposite of it, and you're at -8. Okay? Okay? The only time this could possibly be negative over here is if there's a negative sign on the outside. Make sense? Okay? That shouldn't be anything different from your ALG1. Okay? Okay, let's look at some examples. They will say solve. That's the directions. Okay, and let's say they give you the absolute value of 2x minus 3 equals 7. On absolute value, because this part inside, if I cover this up, this part inside could be 7. Absolute value of 7 is 7. Absolute value of -7 is 7. So this part, there's going to be, on absolute value, you're always going to have to work 2 cases. Okay? So you pull what's inside the absolute value and just work that case. What determines if, and we'll get into some more of this when we get to the inequalities, but what determines on the 2 cases if it's an and or an or is that sign in, bless you, that sign in between. Okay, if it is an equal sign, it will always be joined by the word or. Okay, so that equal sign, okay, you may want to draw a little note out the side. If it says absolute value equals something, then use or between the 2 cases. That will change on examples when we get to inequalities. For right now, we're just doing equal signs. Okay, so you take what's inside, to work these, you always take what's inside the absolute value, and then just bring this down. Now take what's inside the absolute value, and then take the opposite of this. Okay, so take 2x minus 3 equals the opposite of 7. That's the other case. Okay, some authors actually do a parentheses and a negative and leave this positive, but your author doesn't. Your author works it like this. Now you work both cases. Okay, nope, now we got to solve it. We're going to get 2 numbers. So 2x, do the inverse, add 3 to both sides. 2x equals 10, divide by 2, x equals 5. Or, you have to have that or in between. And or is actually in math called a disjunction. And is a conjunction, or is a disjunction. Okay, and now add 3. Divide by 2, and I get x equals -2. Okay? Now, the critical part about this is you're not done. Okay? You have to check your answers. Okay, there will be some that are what they call extraneous roots, which means they're answers to this equation, but not necessarily answers to this one. So you have to, it's critical, star it, highlight it, whatever you got to do, it's critical to check your answers. Okay, so if we substitute back in, and we got to do 2 checks, so let's put 5 back in. So 2 times 5 minus 3 equals 7. 2 times 5 would be 10 minus 3. So we got the absolute value of 7 is 7. 7 is 7. Yeah, that checks. Or the absolute value of 2, put -2 in for x. So you'd have -4 minus 3 equals the absolute value of that 7. Absolute value of -7 is 7. 7 is 7. Yeah, that checks. Both answers work. There will be times where some of them won't work and you have to reject it. And it's joined with an or. You really should have, on any equal sign, between absolute values, you need that or. I get real picky. Geometry kids can vouch for that. Okay. Everybody good with that answer? Yep.
So why do you have to do both? Like why? Like in the positive one?
Because there's on an absolute value. Like when I do, if I did this, yeah, you can go both. You can get two answers. So if I did, come on, if I did the absolute value of 5, there's 5. The absolute value of negative 5 is 5. So I got two possibilities inside there. So I got to work both. Absolute value, you will always work two cases. Okay? Okay, let's go back. Let's try another one. Absolute value of 6 minus 4y, close the absolute value, plus 5 equals 0. Okay, to work that, you got to get that absolute value by itself. So subtract 5. Take the 5 over. Absolute value of 6 minus 4y equals a negative 5. Tell me, is that ever going to happen? Is the absolute value by itself ever going to be negative? No. Empty set, that's the symbol for the empty set in math. Or you can say no solution. Okay, because I don't care how hard you try, any number you put in there, when you take the absolute value of it, it's going to be positive. Okay? So, if you get an absolute value equal to a negative number, yay, just say no solution. This is the symbol, if you have not seen that before, that is the symbol for the empty set. And that's all you need to write. I mean, this is okay to write empty set. You're done. Or if you don't like writing that, you can say no solution. Okay? That was a great problem. Okay? Another example. Absolute value of 8 plus y equals 2y minus 3. Okay, you need two cases. Take what's in. You can't combine like terms yet, okay, because one's in the absolute value. So you take what's inside the absolute value and set it equal to the other part. That's one case. Or you take what's in. It will always be take what's inside the absolute value and then take the opposite of what's on the outside. And basically when I'm doing that, I'm using this part of the definition when I'm doing that. I'm taking the opposite of what's on the outside. Okay? Okay, so now you work both parts. We got two problems. So the bad part with absolute values is every time I give you an absolute value problem, I'm giving you two. Okay? Okay, so solve. I'm going to get the y's together first. And I get y equals 11. You agree with that? Check up here. Did you get the y's together first? Did you bring the 8 over or bring the 3 over? Okay, so add 3. That would be positive. Find your error. Okay, found it. Okay, good. Okay, now distribute this negative sign. Distributive property. So I have 8 plus y equals negative 2y plus 3. Good with that? Get the y's together. And I usually get them positive, so I'm going to add 2y. And then I'm going to subtract 8. I get 3y equals a negative 5. Divide by 3. And I get y equals a negative 5/3. Okay? Now let's check. You got to check both of them. Okay, so you can't highlight your answers until you check it. Okay, so let's check. Go back to the original. This is our check out here. So we got to substitute 11 back in. So this would be absolute value of 19. 22 minus 3, absolute value of 19 equals 19. 19 equals 19. Yep, I'm good with that. So that's an answer. Okay, now let's check the other one. You got a little separator. Go back to, when you check it, you have to go back to the original problem. You cannot plug it back in here. Because if it's an extraneous root, it would work back in here, but it doesn't work in here. So you got to go back to the original. And yes, you do have to work with fractions in here. Just get used to it. And if you don't know how to work with fractions, you will. You'll learn. Sub in. Okay, and let's go to thirds. This is like get a common denominator. So this would be like multiply this by 3. It would be 24 plus a negative 5 thirds. I get 19 thirds over there. This would be a negative 10 thirds. Okay, so on this, look right here. You could stop right here. Do you have to finish it? Can this absolute value be negative? No. Reject. There's only one answer. Okay, so that is not an answer. This is our answer. Y is 11. It's because this absolute value cannot be negative. So I don't even have to finish it. Okay? Yep. Is that good? Okay, enough examples. For every absolute value problem, you take what's inside the absolute value and set it equal to that number. Or, on this one we don't have an or because there's only one answer. Or when you work it, it's an or. Take what's inside the absolute value equals the opposite of that and work both cases. It is critical that you check your answers back in the original because you will reject some and that will cost you points if you don't take time to check it. So a big thing, like if I was studying for the test, a thing I would put up at the top of that paper, check your answers. Okay, you got to check your answer in the original. Okay, any questions on that? Okay.